Chemistry virtual lesson. My name is Michael Faribault, and I teach AP Chemistry at Albemarle High School in Charlottesville, Virginia. Today, the topic of today's lesson falls under Unit 9. Now, we've talked about this before, you may remember this, but if not, I'll go ahead and give you the disclaimer that on the AP exam this year in 2020, it covers units 1 through 7, but the College Board and colleges have decided that there are certain topics in Unit 8 and Unit 9 that are still worthy of study and focus, especially as you prepare for your next course in chemistry in college. So I will focus today on topics that are very important in chemistry, but will not be covered on this year's AP Chemistry exam. A reminder to students to go to apstudents.org/exams2020 to get more information about the format of the AP exam. For chemistry, the AP exam date is May 14th. And there's information here on the screen about the different time zones in which you'll be taking the AP exam, depending on where you live in the world. And there are 2 free response questions on the online AP Chemistry exam this year. So let's get into our lesson for today. Hopefully you have access to a periodic table, scratch paper, something to write with. We'll talk about in Unit 9, entropy, Gibbs free energy, thermodynamic favorability, and the connection between free energy and equilibrium and dissolution. And you can see not only the topics here, but also the skills and science practices. So in our overview today, I'll talk about entropy, free energy, and thermodynamic favorability, and as free energy relates to equilibrium and dissolution. Our warm-up problem for today's lesson is the AP Chemistry practice exam question that I had given you in yesterday's lesson for homework. And so this question relates to solubility equilibria. So we have a saturated solution of magnesium fluoride, MgF2, and that was prepared by adding 0.50 grams of solid magnesium fluoride to 100 milliliters of distilled water. Now again, it's a saturated solution, so we have to assume that not all of the solid dissolves, and at the end, this saturated solution most likely has some solid magnesium fluoride that is on the bottom of the beaker. Now, when this saturated solution is analyzed, it is determined that the concentration of the fluoride ion in this saturated solution is 2.4 times 10 to the minus 3 moles per liter. All right, so Roman numeral 1 of this question, write the chemical equation for the dissolving of solid magnesium fluoride in water. So we have our solid magnesium fluoride, and it dissociates into magnesium ions and fluoride ions. So make sure that you balance your equation and that you include the charges on the ions. You don't necessarily have to include the phases of matter, in this case S for solid and AQ for aqueous, but I just did that just to be complete. Definitely make sure you have the correct symbols, charges, and that the equation is balanced. The next part of this question asks us to calculate the number of moles of magnesium fluoride that dissolves. So we are not going to take the 0.50 grams of solid magnesium fluoride and convert that to moles. We have to assume that not all of that solid actually dissolves. Now we are given a number, and that number is the molarity, so the concentration in terms of moles per liter of the fluoride ion. But remember that there is a 1 to 2 mole ratio between the number of moles of the magnesium fluoride and the number of moles of the fluoride ion. So we have to make sure to include that 1 to 2 ratio in our conversion factor. Otherwise, if we calculate the number of moles of the fluoride ion, that will not be the number of moles of the magnesium fluoride. It would be twice as much, so we'll have to cut that number in half. So we'll start with the 100 milliliters, which is the volume of the saturated solution. We're going to use molarity, as a conversion factor. So I could write 2.4 times 10 to the minus 3 moles of fluoride over 1 liter. I have chosen to write 1,000 milliliters instead of 1 liter, but that's because I wanted to get the milliliters to cancel out. Now, the second step is to convert moles of fluoride into moles of magnesium fluoride. There's that 1:2 ratio I mentioned. And so if we do this math, we get 1.2 times 10 to the negative 4 moles of magnesium fluoride. So that is considerably less than the amount of moles of magnesium fluoride that was added. That's how much actually dissolved. Now, for the next part of this question, they want us to calculate the value of the KSP. So the KSP would be the concentration of the magnesium times the concentration of the fluoride squared. So remember that the concentration of magnesium is not 2.4 times 10 to the minus 3, but rather half as much. If we plug in these numbers into our KSP expression, that's 1.2 times 10 to the minus 3 times 2.4 times 10 to the minus 3 squared, then we get our value for the KSP, the solubility product constant for magnesium fluoride, 6.9 times 10 to the minus 9. All right, so we have a part B of this question, and now we're done with magnesium fluoride, and we're going to talk about some other fluoride salts from the alkaline earth metal family. We have calcium and barium. So a beaker contains 500 milliliters of a solution in which both calcium ions and barium ions are present in a concentration of 0.1 moles per liter. The student intends to separate the ions by adding 0.20 molar sodium fluoride, 1 drop at a time, from a burette. And they're giving us the KSP value for calcium fluoride and for barium fluoride. You can see that they are different. So calcium fluoride's KSP is about 5 orders of magnitude smaller than barium fluorides. And that we can take advantage of that difference in KSP because it helps us understand that there's going to be a difference in solubility. Which salt will precipitate first essentially is asking the question, which salt is less soluble in water? And hopefully you remember from yesterday's lesson, the smaller the KSP, the lower the solubility. So the value for KSP for calcium fluoride is smaller than that of barium fluoride. So therefore, calcium fluoride has a lower solubility, and calcium fluoride is the salt that should precipitate first. Well, that was just qualitative. Now we'll actually do a quantitative calculation. Calculate the minimum concentration of fluoride necessary to initiate the precipitation of the salt. So we have 0.1 molar concentration of calcium and barium. And this is our KSP expression for calcium fluoride. Let's plug in 0.1 molar for the concentration of the calcium and then solve for the concentration of fluoride. This will tell us the minimum concentration of fluoride necessary to initiate precipitation of the calcium fluoride. So we'll go ahead and multiply both sides by 10, essentially dividing by 0.1. So now we have F squared, the concentration of fluoride squared is 3.5 times 10 to the minus 10. And then we have to square root this answer, or square root the number to get our answer. So the concentration of fluoride is 1.9 times 10 to the minus 5 moles per liter. That is the concentration of fluoride needed for the first grains of solid crystal calcium fluoride to appear. So now that we know that number, calculate the minimum volume of the 0.2 molar sodium fluoride that must be added. And again, we're assuming that the amount of sodium fluoride is so small, it doesn't change the total volume. So we still have essentially a 500 milliliter volume of solution. And then the concentration, 1.9 times 10 to the minus 5 moles of fluoride per 1 liter, or 1,000 mils. So this number, 9.5 times 10 to the minus 6 moles of fluoride, that needs to come from a solution that has a concentration of 0.2 moles per liter. we're going to use the sodium fluoride molarity as a conversion factor, but this time putting moles on the bottom and volume on the top. So how much sodium fluoride do we need? A very small amount. In fact, less than 1 milliliter. So what I did was I multiplied volume times molarity to get moles, and the molarity was from Roman numeral 2 in this problem. Then I did moles divided by molarity, essentially, to get volume. So in the official scoring guidelines, you'll see a slightly different approach to what I did, and they still get the same answer. So they did M times V equals M times V, since the moles are not changing. So 0.2 molar, which is the sodium fluoride, times some volume we don't know yet, equals the 1.9 times 10 to the minus 5 molarity, which is the concentration of the fluoride needed, and then times the volume of the solution, the 0.5 liters or 500 milliliters. So as you can see, they got 0.047 or 0.048 milliliters. All right, there was a part C of this homework question, and it says, there are several ways to dissolve salts that have limited solubility. Describe one procedure to redissolve the precipitate. So one way to redissolve a slightly soluble salt is to add more water. Another way would be to heat it up, increase the temperature. Any valid statement that implies a shifting of the equilibrium toward the products. So they also mentioned adding acid. So the fact that calcium fluoride dissociates into calcium ions and fluoride ions. I talked about this in yesterday's lesson. It turns out that since fluoride is a weak base, adding H+, it will react with the fluoride, causing this concentration of fluoride to go down as it forms the molecular version of HF, the hydrofluoric acid. So as it decreases that concentration of fluoride, then that will shift the equilibrium toward the right. So again, either adding more water, adding acid, or heating the solution would increase the solubility. All right, so for today's lesson, I'm going to start with entropy. Now, entropy is famous, or maybe I should say infamous, for being poorly understood by students. It's a difficult concept to teach. Many teachers try to use analogies, and the analogies sometimes create misconceptions. So one of the most common analogies for entropy is disorder. Disorder, randomness, chaos, a messy room, a shuffled deck of cards that's dropped on the floor so that the cards are scattered. So the problem with saying entropy is disorder is it's actually more complicated than that. I'm not going to go into the great details today of things like microstates, but I'm going to go ahead and define entropy in a way that will help you earn credit when you answer a question on an exam. Now, it may not be on this year's AP chemistry exam in 2020, but for any chemistry test in which you have to justify your answer, I'm going with the statements and phrases about entropy that I find in textbooks as well as the course and exam description for AP chemistry. So you'll see on the screen definitions of entropy that I think are helpful. So entropy is a measure of how dispersed or spread out the energy of a system is at a specific temperature. Entropy increases when matter and or energy becomes more dispersed or spread out, and we're focusing on the particles of matter or the energy itself. Entropy increases when a substance changes phase from a solid to a liquid, from a liquid to a gas, or from a solid to a gas. Again, all of those phase changes would increase entropy as the particles become more dispersed and spread out. And entropy increases when individual particles become freer to move and generally occupy a larger volume. So for example, if you let air out of a tire, then the gas molecules spread out to a random, more wide spread out region. Entropy increases when a gas expands into a larger volume at a constant temperature. Entropy in a chemical reaction increases when the total number of moles of gaseous products is greater than the total number of moles of gaseous reactants. So if you go from 2 moles to 3 moles of gas, that would increase the entropy. And you may remember seeing Boltzmann distribution curves. So I'll just try to sketch one here real quick. So we typically are talking about something like kinetic energy, or sometimes molecular speed. So I'll just put number of molecules here. And then this could be either energy or speed. So speed, or sometimes kinetic energy, I'll just say KE for short. So you'll notice that when you switch to a higher temperature, this would be a higher temperature, that the area under the curve stays the same, but there is a broader distribution of the energies. So again, entropy can be thought of as a dispersal of the energy. So when the temperature increases, the entropy of the system increases. Now, where on your equation sheet do you find entropy? Well, again, this is our formula for calculating delta S. If you know the entropy of the products and the reactants, you may recall that we've already done work with this equation in Unit 6, talking about thermodynamics and thermochemistry. So the delta H of formation, the enthalpy of formation of the products minus that of the reactants. What's also interesting to note is that while the delta H of formation for an element in its standard state, a pure element in its standard state by definition is 0. Here, these values for elements are not 0. So the delta H has to do with enthalpy and the heat involved, the energy involved in the formation of 1 mole of a substance. Well, you're not going to form 1 mole of an element from an element. So these already are elements. So by definition, they would be 0. But since we're not talking about enthalpy, but rather entropy, the only thing that would have an entropy value of 0 would be a pure crystal that is at absolute 0. So you'll find that if you look up in a table, the entropy values, they will always be a non-zero number. There's a slightly different situation for aqueous ions. Aqueous ions are defined relative to H+, and so you will see a 0 for that. But for a pure substance, solid, liquid, or gas, as opposed to aqueous ions, you will never find a 0 in these tables. All right, so I have an equation, and this equation involves 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of ammonia, NH3, and these are all gases. So think about what I mentioned earlier about the entropy change for a chemical reaction and make a prediction. Should the delta S, the change in entropy for this particular reaction, which goes from 4 moles of gas to 2 moles of gas, should that be positive or negative? So here's a hint. If entropy is increasing, the delta S is positive. If delta S is negative, it means the entropy is decreasing. So think about what happens when you go from 4 moles of gas to 2 moles of gas in terms of the change in entropy. All right, let's go ahead and do the calculation. So we'll do products minus reactants. That would be 2 times the number for NH3 minus the number for nitrogen, and then also minus 3 times the number for hydrogen. And then this math works out to be negative 198.3. So hopefully that agrees with what you had predicted, that when you go from 4 moles of gas to 2 moles of gas, the entropy decreases. And so that's why the delta S is negative. Let's take a look at a few more examples of this concept. Here we have the conversion of ozone, which is O3, to molecular oxygen, O2. Think about whether you should increase or decrease entropy. We're going from 2 moles of gas to 3 moles of gas. So 3 times the number for molecular oxygen. that's the products, minus 2 times the number for ozone. So now we get a positive value, but this should make sense to you. It's a contrast to the last example. Now the number of moles of gas is increasing from 2 to 3, so the entropy increases and we have a positive delta S. All right, here is a phase change from liquid water to steam or water vapor. So think about whether entropy should increase or decrease for this change. Going from a liquid to a gas, think about what the particles are doing, whether they are more spread out or closer together or farther apart. So we'll go ahead and take the 188, which is the number for water vapor, minus 69.9, the number for liquid water, and we get a positive delta S. So as you go from a liquid to a gas, that is a phase change in which entropy is increasing. Here we have 2 moles of solid sodium reacting with 1 mole of gaseous chlorine to produce 2 moles of solid sodium chloride. So think about whether that entropy should increase or decrease and whether the sign of delta S should be positive or negative. So we'll take 2 times the number for NaCl minus 2 times the number for sodium plus the number for chlorine. So we're starting with 2 moles of solid and 1 mole of gas, and we're ending with 2 moles of solid. So hopefully your prediction came true and that the delta S is negative. This tells us that entropy is decreasing as we are converting from essentially a gas and a solid to just a solid. So there are less degrees of freedom and there are fewer arrangements of the molecules and the particles as you go from a gas to a solid. Okay, so I've talked about entropy. I would like to also talk about free energy and thermodynamic favorability. Some textbooks, and depending on your teacher, maybe the teacher might use this phrase, will use the term spontaneous. But the AP course and exam description tends to avoid the word spontaneous, and they instead prefer the phrase thermodynamically favorable. So what exactly is free energy? Well, the amount of energy that is free or available to do useful work. And so if I say a reaction is favorable or thermodynamically favorable, that typically means that it happens all by itself and that can be used to do work on the surroundings. Otherwise, if the reaction is not favorable, then the surroundings would essentially need to supply energy to the system to make that reaction happen. So the delta G is our symbol for the Gibbs free energy change. And we're talking about the little superscript 0 means standard conditions. That's typically 1 molar for aqueous species, 1 atmosphere or 1 bar for the pressure of gases, and standard temperature 298 Kelvin for thermodynamic standard conditions. Now earlier we said that if delta S was positive, that meant it was increasing entropy. And if delta S was negative, then entropy was decreasing. So with free energy, it goes like this. If the change in free energy is negative, then the process is favored to occur at standard conditions. So you actually would have a positive delta G indicating it's not favored. A negative delta G indicates that it is favored. Now, this is not kinetics. This is thermodynamics. So whether it's favored or not says nothing about the rate of the reaction. It could be fast or it could be slow, but if the delta G is negative, this is where I talked about that word spontaneous before. We tend to avoid the word spontaneous because some people have the connotation that spontaneous means fast. And so we're not talking about the rate. So thermodynamically favored just means it's going to happen, whether that takes, 5 seconds or a year. One way to calculate the value of delta G is very similar to the equation I showed you earlier, products minus reactants, where you have a table and you'd be given the standard free energy change for individual chemicals, the free energy of formation. Another way to calculate delta G, and these equations are on your equation sheet, is the Gibbs free energy equation involving all 3 of these concepts: free energy, enthalpy, delta H, and entropy, delta S. These are all combined, and the T stands for the absolute temperature in Kelvin. All right, so free energy and thermodynamic favorability. Well, there are essentially three possibilities for delta G. It could be negative, positive, or zero. If delta G is negative, as I said, it means it's favored. The forward process, as in the reaction as it's written from left to right, is favored to occur. But if delta G is positive, then the forward process is not favored to occur. Instead, the reverse process would be favored. Or you could say that energy must be supplied from the surroundings in order to get the forward process to occur. Now, if delta G is neither positive or negative, this often happens for a phase change where, for example, you're melting ice and you're exactly at 0 degrees Celsius or 273 Kelvin. So neither the forward or the reverse process is favored if you have this perfect equilibrium situation where essentially both the forward and the reverse processes are happening at the exact same rate. Otherwise, if K, the equilibrium constant, is large, you're favoring the products. And if K, the equilibrium constant, is very, very small, you're favoring the reactants. And we'll talk about the relationship between free energy and the equilibrium constant a little bit later in this lesson. All right, so here's some examples of products minus reactants. Notice that the delta G of formation for a pure element is 0, as it was for enthalpy, the enthalpy change of formation. So I have the synthesis of liquid water from the elements hydrogen and oxygen. Products minus reactants gives me a value of negative 474.4 kilojoules per mole of reaction. So what does this negative delta G tell me about the thermodynamic favorability of this synthesis of water? Well, you may have heard of the Hindenburg airship that burst into flames. And again, hydrogen was inside the ship. You may have done experiments in your chemistry class involving a little popping sound as a test for hydrogen gas. Hydrogen, the combustion of hydrogen, although it does need a spark or an ignition source to get it started, it is thermodynamically favorable. So once you can get the reactants over the activation energy barrier, which is what that spark is doing, then the reaction starts and it proceeds on its own. And one of the examples of free energy, how it can do useful work on the surroundings, is the launching of something like the space shuttle. So that's powered by hydrogen and oxygen. So obviously doing very useful work in that situation. What if I take the synthesis of water and write it backwards? If the forward process is favorable, then what do you think about the reverse process? Well, hopefully you understand if I take negative 474.4 and just flip it around, I now have a positive. So this is not the synthesis of water, but rather the decomposition of water. So the electrolysis of water can occur, but it's not thermodynamically favored. It doesn't happen all by itself. So energy in the form of a battery or some power supply must be provided from the surroundings to the system for that reaction to occur. Here's another example of a decomposition equation, a reaction. This is hydrogen peroxide, H2O2. I'm going to go ahead and think about hydrogen peroxide in terms of what you might find in your medicine cabinet somewhere at home. I'll do the math of products minus reactants, and I come up with a negative value. Now, the decomposition of hydrogen peroxide is favored, however, without an enzyme. So when you pour hydrogen peroxide on a scrape or cut and it fizzes and foams and sometimes stings, the enzymes in your skin called catalase are making that reaction go faster. You can also add various chemicals like potassium iodide or manganese dioxide to catalyze the reaction. Just because it's favored doesn't mean it's fast or slow. So remember that in general, thermodynamics will only tell you if it's favored or not, but it says nothing about the speed with which the reaction occurs. In general, if the activation energy tends to be relatively high, then the reaction will usually occur rather slowly. So if you are asked a question, explain why, although a reaction is favorable, it doesn't seem to occur at a very observable rate, you could talk about the activation energy being high, and that's why the rate of the reaction is slow. All right, here's another reaction. This is the decomposition of calcium carbonate, which is found in limestone, and it decomposes to give calcium oxide and carbon dioxide. So we now have data for delta H, and that's the enthalpy of formation, and we have S, so the entropy. We'll do products minus reactants for each of these sets of tables. So I have products minus reactants, and I get a delta H of positive 178.5. This indicates that the decomposition reaction is an endothermic process. We're going from 1 mole of solid to 1 mole of solid and 1 mole of gas. Now, gas has typically more entropy than a solid because the particles are freer to move around. There's more arrangements of gaseous molecules than solid particles. So I would predict that the delta S is positive, and that's what happens when I do this math. So I did products minus reactants using the numbers in the table on the left. Entropy increases as 1 mole of solid is converted into 1 mole of solid and 1 mole of gas. The particles are freer to expand into a larger volume. Let's put these two things together. We have a delta H, which is positive 178.5 kilojoules per mole, and we have a delta S, which is positive 159.0 joules per mole Kelvin. Now notice what I did because I was worried about units. So I converted by dividing by 1,000. I went from joules to kilojoules because I wanted the units of delta H to be the same as the units of delta S. So watch out for that. If you're solving problems, pay attention to your units. All right, so delta G would be delta H minus T delta S. Is the decomposition of calcium carbonate thermodynamically favored to occur at 298 Kelvin or 25 Celsius? So there's our equation. We'll plug in our numbers, and again, notice I have changed my delta S into units of kilojoules, so it will match. The kilojoules are going to be present in my final answer. The Kelvin will cancel out. And so I did this math, and I got a positive value. So the answer to this question is no. The decomposition of calcium carbonate is not thermodynamically favored to occur at 25 degrees Celsius. Well, what if I choose a different temperature? It is an endothermic reaction, so maybe I have to heat it up. I'm just going to go ahead and make up a new temperature, and we'll do this calculation again. So is this decomposition favored to occur at 1,000 degrees Celsius, which would be 1273 Kelvin? So I'm going to go ahead and assume that the delta H and delta S values are going to remain the same. That's my assumption. All I'm doing is plugging in a new number for the temperature. And now when I do this math, the delta G is negative. So it is favored to occur at 1,000 degrees Celsius, but it was not favored to occur at 25 degrees Celsius. So my next question is kind of related to these two results. Determine the minimum temperature that would be required in order for this reaction to become favored. So how do I switch from not favored to favored? Well, I have to heat it up, but at what point? What's the minimum temperature that would be? If delta G is equal to 0, then neither the forward or reverse process is favored. This would be the point at which it switches. So I'm going to go ahead and solve the equation. I set the delta G equal to 0, which means that delta H equals T delta S. Divide both sides of the equation by delta S. Again, watch out for units. So we have kilojoules on both the top and the bottom. Now I'm going to get my answer in units of Kelvin. So around 850 Celsius would be the temperature that would be required at least to make this reaction occur. Okay, so I want to talk a little bit more about the connection between free energy and temperature. Now, focusing on our delta H and our delta S, there are 4 possibilities. We have in the first row of this table here what I'm going to call this a best case scenario. And then the next row of the table, I'm going to call this a worst case scenario. And then in these examples, I would say in general, it depends. Well, it depends on what? It depends on the value of the temperature. So in terms of the T and the delta H minus T delta S, then that temperature is going to be important in certain situations. Okay, so best case scenario, if delta H is negative and delta S is positive, then delta G will be negative no matter what. So favored at all temperatures. Unfortunately, if we go the other way, delta H is positive and delta S is negative. Hopefully you can see by plugging those values into the free energy equation there at the top left, that's going to make delta G positive no matter what. So not favored at any temperature. Now, if they're both positive, delta H and delta S are both positive, then you would want this portion of the equation should get your focus. So if delta H is positive, that's not going to help our situation. We're trying to get delta G negative. So that would only be favored whenever the value of T is relatively high. And if, instead, delta H is negative, so that's a good thing. But now the delta S is positive. If T is rather large, I'm sorry, if delta S is negative, if T is rather large, you have a negative times a negative. So that's actually going to make this term positive and is going to lead to a potentially positive delta G overall. You want the T to be low. So I'm going to go ahead and explain a little bit more about these last two scenarios. When I say favored at high temperatures or low temperatures, what does that mean? So these are my it depends situations. Okay, so I want delta G to be negative. That means it's favored. This is not helping me. However, this is a good thing and therefore could potentially make the overall value of delta G negative as long as this T is large enough. So you want a high value for temperature because then this portion will be negative and make the overall delta G negative. You can also think of this in terms of Le Chatelier's principle. So we have a positive delta H, which means we have an endothermic reaction. You may recall from an earlier lesson that as temperature is increased, the endothermic reaction will shift in the direction of the products. That would make the reaction more favorable. So an endothermic reaction tends to be favored at high temperature. Now, if we do the same kind of scenario here, we have delta G is negative. We want this to be negative, so therefore this part, which is the delta H, that's a good thing. But unfortunately, a negative times a negative is a positive. So we do not want this term to overwhelm the delta H. So therefore, only at low temperatures would this reaction be favorable, because if T gets too high, then the T delta S term might have a greater magnitude than the delta H, so low temperatures. And going back to the Le Chatelier's principle situation, if you raise the temperature too high, then what that can do by shifting the equilibrium toward the reactants, it can decrease and potentially make your reaction unfavorable at relatively high temperatures. All right, well, hopefully that helps you understand a little bit more about the temperature dependence of delta G. You might sometimes see a question that asks you about what drives a particular chemical reaction, like what's the driving force? And there are three possible answers. The reaction is driven by enthalpy only, which is delta H. It is driven by entropy only, so delta S, or it's driven by both. Well, if you have a negative delta H and a negative delta S, again, the example being that we're trying to get delta G negative, so this would be a good thing, and this would not be a good thing. So focusing on the enthalpy only, if delta H is negative and delta S is negative. Now, driven by entropy only, if you have a positive delta H, this cannot be the driving force because, again, you're trying to get delta G negative. This positive delta S is helpful because, again, that makes this T delta S term overall with that negative sign there, that can potentially be the driving force. So it can be driven by either a negative delta H, or it could be driven by a positive delta S, or if you have both, That's your best case scenario, then it's driven by both. All right, let's talk about free energy as it relates to equilibrium. You should know that K is either more than 1 or less than 1, indicates something about products being favored or reactants being favored. So if the delta G is negative, then we are favoring the products and K is greater than 1. If delta G is positive, we are favoring the reactants and K is less than 1. And there is an equation on your equation sheet that looks like this. So if you look at the natural log portion of this equation, the natural log of a number that is less than 1 will be negative. So a negative times a negative is going to give you a positive delta G. But the natural log of a number that is greater than 1 will be positive. And so you'll end up with a negative delta G. Now, as far as the R, that's the ideal gas constant, we're going to be using this particular value of R because it has joules attached to it. So pay attention to your units. When you have to use a particular value of R that involves delta G in this equation, you want to use 8.314, and that has units of joules per mole Kelvin. All right, I want to talk about free energy of dissolution, then we're going to do some AP chemistry practice. Dissolution means dissolving in water. So I have a chemical called ammonium nitrate, NH4NO3, and I've got some delta H of formation data and entropy data on the left. So the dissolution of ammonium nitrate. What about the delta H or the enthalpy? If we plug in the numbers from the table, we get a positive value. Now you may know this. If not, it's a little fun fact to know. There are some things called instant cold packs. I might have mentioned them in an earlier lesson. Instant cold packs typically contain a substance like ammonium nitrate. And when dissolved in water, there's a little pouch of water on the inside of the bag. So you kind of twist the bag until that little pouch of water breaks. As it dissolves, everything gets cold. So an endothermic dissolution means that the surroundings are actually donating heat to the system and the surroundings get colder as a result. So there is our positive delta H. We're going from 1 mole of solid to 2 moles of aqueous ions. If I calculate delta S from the data in the table on the left, I get a positive delta S, indicating that entropy is increasing. So we might say that the particles are freer to move around as they have broken off the crystal lattice and now can move more freely throughout the aqueous solution. So a positive delta H and a positive delta S. I'm testing you here. What's our value of delta G? I'll give you a hint. This is a soluble ionic compound. It's very soluble. So what would you predict your delta G to be, positive or negative, if this reaction is going to occur? Well, I'm going to go ahead and plug in the numbers. Again, watch what I did there as I divided the delta S by 1,000, so I could get my units in kilojoules, so pay attention to that. And the delta G is in fact negative, negative 4.3 kilojoules per mole, so the dissolution of ammonium nitrate is favored to occur. Is this process driven by enthalpy only, entropy only, or both? So consider the sign of delta H and delta S. Which one or both is driving the dissolution of ammonium nitrate? Well, as I mentioned earlier, when you have a positive delta H and a positive delta S, again, the positive delta H indicates it's endothermic. That can never be a driving force. But a positive delta S absolutely is a driving force. So this is driven by entropy only. So in terms of the dissolution process, you can think of the dissolution of an ionic solid in 3 steps. Now, these steps all happen simultaneously, but let's break it down into 3 separate events. You have the solute, which is the crystal. So that's going to be breaking the attractions, and that would be an endothermic process. So delta H is positive. It's also going to create more freedom of movement, so more arrangements. So delta S is positive. Entropy and the free movement is increasing there. So entropy is increasing. You have to break up some solvent interactions. That will also lead to a positive delta H. Again, anytime you break an attraction or a bond, you're breaking attractive forces that requires the input of energy, so endothermic. And again, we're pulling the particles apart from each other. So again, a positive delta S. Now, whenever the solute and the solvent form these ion dipole forces, there's actually slightly less degrees of freedom for the ions that are now hydrated. So that's actually going to result in a negative delta S. So a reduced degrees of freedom there for those particles that are bound to those water molecules. And again, when you form an attractive force, that is going to release energy. So breaking a bond absorbs energy, forming a bond releases energy. So negative delta H and negative delta S because of a slight decrease in entropy. All right, so I've got some AP practice problems to do, and then that will wrap us up here. Okay, so here are some practice problems that relate to entropy, enthalpy, and free energy. We have an equation. A student designs an experiment to study this reaction. And in thermodynamic terms, a reaction can be driven by enthalpy, entropy, or both, considering that the flask gets cooler as the reaction proceeds. What drives the chemical reaction here? So if it gets colder, like the ammonium nitrate dissolving in water, when it gets colder all by itself, that is an endothermic process. That would be a positive delta H. That is not going to be the driving force. But we know that it does occur. It definitely happens. There's formation of bubbles. So this reaction does occur, but it's driven by entropy only. So reactions are thermodynamically favorable when delta G is negative. Since the reaction is endothermic, the flask gets cooler, delta H is positive. The reaction is not driven by enthalpy because enthalpy does not help make delta G negative. Because there are no gases in the reactants and one of the products is a gas, delta S must be positive, which helps to make delta G negative. So driven by entropy and the formation of the gas, increasing entropy. All right, here is a new question. You might have a little deja vu on this question. We did talk about this in an earlier lesson in Unit 6. This is calculating the delta H by doing bonds broken minus bonds formed. So you may have to watch that earlier lesson because I'm going to go ahead and just cut to the solution there that I had already shown you in an earlier video. So it's a conversion from fulminic acid to isocyanic acid. That's 1 mole of gas going to 1 mole of gas. And we have now calculated from the bond enthalpies that the reaction is exothermic, so negative delta H. A student claims that the reaction has a delta S close to 0. Explain why the student's claim is accurate. So we're not changing phase here, and we're not changing number of moles. So the change from fulminic acid to isocyanic acid is a rearrangement of the atoms, but there's no change in phase and no change in the number of molecules, so delta S should be pretty close to 0. Which species, the reactant or the product, is present in higher concentration? This is our connection between delta G and the equilibrium constant. Well, we know that delta G equals delta H minus T delta S. We've already established that delta H is negative and delta S is pretty close to 0. So therefore, delta G is essentially equal to delta H. So we have roughly negative 246 kilojoules per mole for our delta G. That means that the reaction is favorable. Since delta G is negative, that means that K, the equilibrium constant, is greater than 1. There should be more products than reactants. So the product, isocyanic acid, will be present in higher concentration. We made the connection from delta G to the equilibrium constant being greater than 1. All right, here is a new practice problem. We have an equation between NO and NO2, so nitrogen monoxide reacting with nitrogen dioxide to produce N2O3. We have to calculate the value of the equilibrium constant, and we are given the delta G in the table. So we're going to calculate the value of the equilibrium constant by rearranging this equation, which is given to you on the equation sheet. I'm going to divide both sides by the negative RT, and then I have to do the opposite of a natural log, which is the E raised to that power. Now be careful that you have to focus on your units, because this delta G is in kilojoules, but the R, the ideal gas constant that we're pulling off the equation sheet, is in joules. So watch out, you don't put in 0.87 on the top there, but rather 870, because that would have units of joules. Alternatively, you could have divided 8.314 by 1,000. So either one, just pay attention to your units. I did this math, and I got that my K happens to be a little bit less than 1, so it's 0.7. Next part of this question says, if the pressure of the nitrogen monoxide is 1 atmosphere, and the pressure of the nitrogen dioxide is also 1 atmosphere, will the pressure of the N2O3 be 1 atmosphere at equilibrium? Look at that value of K. Is that relatively large or small? Well, K is less than 1. That means that this reaction does not go to completion. The only way the pressure of the N2O3 would be 1 atmosphere at equilibrium is if the reaction went to completion. Since K is less than 1, this indicates that there will still be a certain amount of reactants present at equilibrium, so we disagree with that particular question there. A student hypothesizes that increasing the temperature will increase the amount of N2O3. Okay, so if you raise the temperature, are we going to shift this equilibrium toward the formation of N2O3? Well, that would be true if we have an endothermic reaction, but we don't. We have an exothermic reaction, so I disagree with this hypothesis. This reaction will be exothermic because delta H is negative, so therefore with an exothermic reaction, increasing the temperature will actually shift the reaction toward the left, the reactants. This would cause the amount of N2O3 to go down, not up. All right, so some more practice problems. Here we have the dissolution of a chemical. This is called urea, and it's featured right up here. And it says, calculate the concentration of the urea. So we're given information about grams. We can definitely convert from grams to moles. And then moles divided by volume in liters. So that problem gives us 17.9 moles per liter. The student also determines that the concentration of urea at 25 degrees Celsius, not 20, but 25 degrees Celsius, is 19.8. So what just happened is we raise the temperature and we increase the concentration. That results in a shift toward the products. That indicates that the reaction must be endothermic, because when we raise the temperature, we increase the concentration of the product. That's Le Chatelier's principle. This is about a procedure for making the reaction. Well, actually not really a reaction, but a dissolution. And it says, list the specific measurements that are required. So you don't actually have to write a procedure, I'm sorry. You have to actually write the measurements. And the measurements would include, let's measure the mass of the urea, the mass of the water, initial and final temperature. There were students on the AP exam that got this question correct, but they wrote an entire procedure. Didn't have to do all of that, just simply list the measurements. Delta T, by the way, is not a measurement. So initial temperature, final temperature, those are measurements. All right, so we have an entropy. Delta S is 70.1. That's products minus reactants. So we have 70.1 equals the product, which we don't know right now. That's the question mark in the table, minus the reactant, 104.6. And we just solve and we get 174.7. I'm going to tell you right now that looking at the clock, I know I'm going to wrap this up pretty quick, so I want to thank you for hanging in there with me. The good news is there's not going to be any homework in today's lessons. I'm going to explain that in just a second, but feel free to pause the video because I am going kind of fast through these last few slides to finish up our discussion of free energy, entropy, and thermodynamics. They're asking for a particle level explanation for why the delta S is positive. It has to do with the fact that the particles are more free to expand and move around. Definitely want to talk about the particles in this case being more free to expand and move around or have a greater number of possible arrangements. So delta S is positive for the dissolution of urea. And student claims that the delta S contributes to the favorability. We already know that this is an endothermic process. Okay, that was mentioned earlier in this question. I'm not sure if I talked about that, but anyway, it is an endothermic process, but we're talking about delta S specifically here. So a positive delta S will lead to a negative delta G. So when delta S is positive, yes, this does contribute to the favorability of the dissolution. Now, the reason why there is no homework is that next week, Mr. Byrne and I will be teaching lessons focused primarily on AP practice. So that means that our practice will happen in the lesson. So no AP chemistry questions to practice because you'll be doing a lot of FRQ practice. So today's lesson was on Unit 9, entropy, free energy, and as it relates to thermodynamic favorability. I want to remind you to check out the helpful chemistry resources in the video description. Again, this has been Michael Faribaugh from Albemarle High School in Charlottesville, Virginia. Today is the deadline. If you have not contacted the College Board about your need for mobile tools or connectivity, let them know by filling out the survey at cb.org/tech. So next week, we'll do lots of FRQ practice and preparation for the AP chemistry exam. Thanks for watching and have a good weekend.
All right. Let me pull up the agenda. But in the meantime, hey, I want to see everyone. Why are you all? I guess a lot of you just woke up, right?
We're here.
Okay.
We're here, Dr. Moon.
Make sure you groomed well. Okay, cool. Let me move this out of the way. Okay, there's a couple of things that I wanted to breeze through before we chit-chat. Okay. I don't know why it always does it this way. I guess because my laptop is actually considered the primary screen. And then the connection or the extension monitor is, I guess, the presentation screen. So it's designed in that way. Somehow I haven't discovered how to reset that if it's a setting at all. But anyway, let me go ahead and jump right into it because the College Board video went over time today on a topic that's really not covered in the AP exams, but it's really the reason why I'm recording it because I don't know how long the videos in College Board are going to be available. And I want to have the ability to use it later on. And that's the reason why I've recorded all the videos. And I uploaded it in my own website, in my own YouTube channel, so that it's available for me and for my students anytime. Okay? But I did want to go over some important stuff with you now that we're midway into online learning for Fort Bend, and I was thinking of how to actually think about this discussion that we will have. Um, and the way I thought about it is I entitled it Road Ahead is because I wanted to move to look beyond April and looking into the rest of the school year. How does that look like? Okay, now that we're halfway through online learning. And so um, in order for me to do that, I wanted to just touch on what we've done so far. We've gone uh, we've if you look back, we actually got so far so quickly um, in terms of how we do things. Everyone, I think, or at least I've settled into a routine. I don't know about you, but I have settled into a routine, both good and bad routine, I might say. But uh, let's talk about the positive. A good routine is that I can estimate my time, uh, how much time I need to devote on certain things, including not just for classes but also personally. Okay, devoting personal time for myself. Okay, so that's the reason why I was thinking, okay, if I'm on this, if I'm thinking like this, how are my students doing? How is everyone else doing? Okay, and you may or may not have seen the video that I did already yesterday, and so you might have an idea of where my state of mind is when it comes to that. Okay, so that's this one. Um, the weekly snapshot, I'll probably gonna be hitting this anyway when I get into the last three things I wanted to discuss. So let me go ahead and jump right into it. Just as a reminder, it's 20 days before the exam day, which is May 14th. And I'll also touch base on that in the last three items that I wanted to cover. Okay, so without further ado, let me jump right into it. Okay, biggest concern for everyone's in everyone's mind is what's the game plan for reviewing for AP exams? Because up to this point, all I've been doing is really relying more on you doing your thing, and my role I've seen is to provide you with the opportunity to for reviewing, just give you some guidance and direction. So starting today, I wanted it to be more directionally um, geared. And the way I'm going to do that is I've actually prepared 5 diagnostic exams or diagnostic tests. All of them are in AP Classroom. And I thought of doing that instead of OWL because for one, the questions that are there are already up to the rigor of AP testing. In fact, the way I filtered the questions that I chose, I filtered them so that they're extremely close to exam quality. They're not formative questions. They're not necessarily questions that are just designed to test whether you understood certain concepts or not. They're the I'm more concerned about the rigor of the question, and that's why I chose those questions the way I did them. And so I created 5 of them. The first 2, and this is not going to be in chronological order. The first 2 are actually long free response diagnostic tests, and that's the dark green ones here. And I purposely placed them on a Friday. It starts on a Friday because I wanted it to be a window, Friday to Monday. And the reason for that is because it's long, but I do want you to actually take your time to sit down and test yourself, try to answer the questions, maybe do chunks of, because there's about 6 to, let me just give you a run through. There's about 7 questions on the first diagnostic and 6 questions on the second diagnostic. But it's going to take you about 115 minutes on the first one, 120 minutes on the second one, because of the fact that I made sure it covered the whole breadth of the coverage, unit 1 to 7. So when you take this diagnostic, it's not going to focus on certain units. It's actually going to cover all 7 units. And the reason why I wanted to do that is because I wanted you to get a feel for how the questions interrelate to one another. But at the same time, when I do the analysis of it, I want you to see where your weak points are in terms of units, if there are any. And then you can direct your review accordingly. Because the strategy that I have has always been, and I've been consistent with this since the very beginning, even in my unit tests, the strategy is to answer as many questions as you can consistently on a daily basis so that you can have a better understanding of your weak points, and then you focus your review on those weak points. Okay? That's called studying smarter. If you feel like you're overwhelmed right now, it's probably because you don't know what to review and you don't have a strategy for reviewing. And this is the strategy for it. This is the smartest way to do it. Answer a diagnostic test and then rate yourself. See what units and topics you're consistently missing, and that means you don't have enough information to answer it correctly, or you have a misconception on that topic, and then you review on that, and then try more questions on that topic until you get it. Because there's no sense for you to review periodic trends if you're already getting all the questions on periodicity and the periodic table anyway. Okay? And so why would you stress about reviewing that topic if you have enough information to, when faced with a question, you're able to get the right answer anyway? Make sense? So that's the strategy. Okay? So in terms of timeline, and I'm going to be posting this, by the way, in my online learning so that you have a timeline of leading up to the exam, what to do. And if you look at this, it fits in one slide, which means it's really, really close. Before you know it, in a blink of an eye, oh, it's exam day. Okay? It's the 14th. That's 3 weeks from now. All right? So this is the schedule. Free response 1 is already open. It just opened midnight today. I mean, it's already open, so it's midnight earlier. And it's gonna close around 11:45 on Monday. I'm emphasizing 45 because there's no option for me to do 55, 59, so don't ask me that question, okay? But it's a window, so 115 minutes, I'm hoping you can spend time over the weekend to actually do that, okay? And then on Tuesday, there's going to be a free response diagnostic test 3, but this time it's only about 50 minutes. And my idea about this, it's only going to be open on Tuesday. My idea about this is that you are given an opportunity to do it online in a more exam mode setting. These light green ones, there's 3 of them, 3, 4, and 5. They're uh, they're designed such that it mimics the exam that you're going to be taking, meaning it's 2 questions. The first question would require you 25 minutes. It's a long exam. The second question is a short one. And in between, there's a 5-minute window that where you can upload your stuff. Okay, so that's how this short diagnostic tests are designed, but I'm limited by the questions that I have. And so this will not cover all the units, definitely. Okay. And then on Wednesday, that's when I would want to look at the results of the first diagnostic and even this diagnostic 3. And then the next one, which is a week before the exams, I'll do the other 2 diagnostic and the long one. And the way I'm gonna do it again is we'll break it down by concept, by unit at the very least, so that you have an idea where your weak points are, individually and as a class. Okay, but right now I'm really more focused on the individual results, because after that, then I'm going to rely on you to do independent review. I'll still provide you with materials, but if you already have materials, like you have AP Chem review books, go ahead and start working on those if you haven't done so yet. And on a daily basis, on our virtual office hours, that's when you go in and ask your questions, and I'll address it on an individual basis. Okay? That's leading up to the exams. So that's the game plan. Okay? So again, just to summarize, this is how the schedule is going to go. This is more chronological in order. Okay, so this is the timeline for it, and these are the time limits set. The free response analysis would cover this diagnostic test, obviously the ones that came before it. Okay. So far, any questions regarding this game plan? Any suggestions if you have? Let me pull up the chat, because if you're typing something, I'm not able to see it because I'm not able to see the chat. Okay, nothing so far. All right, so let me go ahead and shift gears. And of course, this is for the AP exams. How about grading? And okay, I shouldn't be using the term grading. I'm actually going to be using the word rating, because you very well know already that P4, we're not actually going to give you a numerical grade. We're just going to give you a rating of either met standard, did not meet standard, or has not engaged. Those are the only 3 things you're going to see, okay, in Skyward. And in fact, we are getting set to place in the first rating, and it's only going to be 1 rating. That's going to be for progress report 8, and you're actually going to receive that, your parents are going to receive that rating on Tuesday, okay, the 28th. And it's only going to say one of those 3 things: M, DNM, or HNE. Okay, met, did not meet, and has not engaged. Okay, now the basis for that is, I've been giving you lessons. The basis for that is up to lesson 10, because the due date for lesson 10 is actually today. And so you should be finished with lesson 10 by today, and I can use it for grading, for giving a progress. And basically the way this is going to work is this. Okay, there's going to be 3 categories really. The first one is about unit 6 thermodynamics, which we just wrapped up. I gave you 6 lessons on it, where I individually broke down the concepts, and then I gave you OWL assignments. So the OWL assignments are the blue ones. The lessons I gave you for the individual pieces, where you actually practiced one concept a day, are these ones here. I really don't know how to call that color, but it seems different from the other colors. That's why I used it. Some people call this flesh or something, but it's totally different in color. Okay, so the first 3, if you recall, April 3rd is when we started online learning. That's when we posted lesson 3. So anything before lesson 3 really doesn't count. Lesson 3, 4, and 5, you're gonna have individual ratings there, and then we'll average it out for you to have a rating, and that would be your rating for evidence 1. Okay. So again, it's just 3 of those. The second one is the next 3 sets. This is the first, basically this first week of content learning. This is the second week of content learning. And this would be the third week of content learning. So this is a Tuesday, Thursday, Friday, right? So that's how we arranged it. This was a Friday, Tuesday, Thursday, but there's no Friday here, and because that was when we were out for Holy Week. Okay, so basically you're gonna have a rating here of 1 of the 3, and then a rating here for 1 of the 3, and then a rating here for 1 of the 3. You average that out. That's your rating for this unit, if that makes sense. Okay, and then the diagnostic review is, the first one is going to be evidence 1, the second one is going to be evidence 2, and then evidence 3 is just going to be the progress checks that we've been doing. Okay, and then the last one is the one for next week, which are the individualized review leading up to the AP exams. Okay, and that would be that would be your last pieces of evidence. If you notice, I placed here AP exams. That's actually one of the evidences. You will be taking an AP exams. It's either my version or your version, or the actual version. So if you take it on the 20th, on the 14th, that's 20 days from now, we actually get the results of that on the 24th. Okay, they will be sending us your answers. They will make it available to us, kind of like the progress checks, and so I can give you a rating for that. And that would be your second piece of evidence. Now, if you chose not to take it on the 14th, then that means you're gonna have to take it on the 2nd, and obviously that's beyond the end of the year. So the idea there is that if you don't intend to take it on the 14th, I'll have a different test for you to take. Okay? And you'll have to take it before the end of the year, because that's one of the pieces of evidence. Otherwise, that means you're gonna end up here as one of the other 2 besides the Met standard, and that would mean that you're gonna have to do some remedial. Is that making sense to everyone? All right. So that's your T4 rating. Any questions on T4 before I move on? None? Okay. So,
Wait, I have a question.
Yeah.
How would you rate our AP exam? Will it be based on like our score?
No, it's not necessarily on the score, because in the first place, there is no rubric for this AP exams yet. it's gonna be based on really. I mean, if I'm gonna score it, I'm gonna score it based on my perception and my grading scale. It's not based on AP College Board because they're not gonna even have a rubric for it until they start checking it in June. That's the way the exams work for the free response. Um, the readers actually come together, they look at the question, they answer it, they create the rubric for it, discuss, and come up with a common rubric for grading all the papers. And uh, so it's a process. It's a long process. And so um, when it comes to the AP exams, when I see the results, I'm just gonna be looking at where you stand at, and I'm just gonna create my own rubric for it. Okay, so it's not necessarily gonna be as rigorous as College Board's rubric. I'm gonna grade it the way I would normally grade my exams. Okay, if I need to apply scaling there, I will. But normally, I think of it as numerical. But at the end of the day, it's not a number that you're going to receive. It's actually a rating. Now, having said that, I actually tweaked the way your Schoology uh, results are going to be. So what I did was all of these assignments you see right now, it's now under a different category called online learning. So if you click on Schoology and go to your grades, you will actually see there a category called online learning. All of these lessons are going to be posted there. And if you look at the item beside it, it's actually just going to give you now a rating of M, DNM, DN, uh, DNM, and H and E. It's not going to give you any numbers or numerical grades anymore. It's just a rating. Okay? And hopefully that should ease your stress when it comes to, because sometimes when you see a grade that's like a 60 or a 70, you start stressing out, and that's because you don't know what the cutoff is. Okay, so it's no longer about numerical grade. It's about have you shown me enough evidence to say that okay, you've at least met the minimum standards for a particular concept. Okay. So questions, other questions, clarifications? All right. So the last things I wanted to cover, one thing is I want to actually get a feel for where you are at when it comes to um, state of mind. So I actually created a Menti assignment, and I'd like to pull that up. So if you can, actually go to this site and just share with me what your thoughts are. They're not going to be labeled. Okay, I wouldn't know who submits this, and you can submit multiple times. I gave 10 slots there, but try to write phrases or keywords of what the question is. And the question is basically share anything that you're thinking about online learning. Yes? So just share your thoughts. And this is a very, very general question. Is it easy for you? Is it hard for you? What are your thoughts, feelings about it? What are you using? What are you doing right now to pass the time? Okay. And while you're doing that, everyone got the link? Let me share that again. It's on top anyway. Why is Isabella in my classroom? The campus is closed.
I was very confused for a second.
I'm looking at your faces because I think I'm forgetting how you look like.
Oh, don't forget.
Is that an anime character, Angela?
What is
Hmm?
that?
Do you love anime?
It's just a yellow wall.
No, yeah, you're right. You're right. Which character was that?
His name is Dio. Wait, hold on. His name is Dio Brando.
Dio Brando.
Yeah.
From which? Is it a comic or a TV show?
It's a TV show. It's called JoJo's Bizarre Adventure.
I don't think I've watched that.
No.
You love anime?
Huh?
You love anime?
I mean, I watch it sometimes, but like.
Oh man, it's you, what happened to you?
I got my pet to class.
You transformed. Yeah.
His name is Ace.
Let me see. Okay. Ooh, miss school. I miss school too. Oof. At least. Why is it stressful? Because you're now on your own. Let me see. Most classes slack off. Who's slacking off, you or the teacher? Tiring, huh? Really? More time for hobbies. What kind of hobbies is this? Less time. Oh, painting, huh? Oh, crying. What? Sick. Ooh. I think my eyes started deteriorating since we started online learning.
Same. I'm gonna need to get better glasses now.
I know, but I can't. The problem is my glasses is actually progressive. So the bottom part obviously is for reading, because I'm farsighted, and so I can actually see clearly if it's far, but if it's near, then it's blurry. The problem is, if it's this distance and the height of the screen, it actually ends up me looking at the top portion to be able to read the screen, and it's blurry at this point. So I actually have to lift up my glasses like this so that I can actually read it. Otherwise, I'm also always gonna read it like this, and it actually creates a strain on my neck.
Oh no.
You know what I found the solution for? Some of you might have seen it already. I wear a cap with a paper clip.
Ah, that's very smart.
Yeah, so I do it like that.
You look cool, Dr. Rowan.
I know, I am cool.
Very cool.
There you go. So now my glasses are actually lifted up and I can read clearly. So if you don't mind, I'm gonna do it like that so that I can be able to read. What's
Coolest
a
thing around.
Roblox? Okay, more than one of you actually wrote that down. What's Roblox? Educate me.
I didn't read
don't
Roblox,
define.
but I can explain what it is.
Go ahead.
You wrote it down.
It's like a game, but it has like more games in it. It's very fun.
It's very fun.
Really? Huh.
There's like a bunch of games on this one website, and the
Yeah, you
web
should download it. We can play sometime together.
and
Roblox
a bunch of-
is
Roblox.
a
bunch of
great
different
time
people
waster.
make those games.
I play all the time.
Shrita, are you playing right now?
Are you playing right now?
Actually, okay. Someone mentioned time waster. You know, there's a recent study that came out that said playing mobile games or digital games is actually beneficial right now because
Mm,
it's a stress relief.
That's true.
this is true.
So let's start playing mobile games.
Dr. Rowan, you should get Roblox and add me on it.
Yeah.
Add all of us
Roblox.
on Roblox.
Yeah, add
Roblox
all
is a
of
lot
us.
of fun.
Is it
You
a
said you might
website
use it on
or
the
what?
Yeah, it's
It
a
is a
website.
website, but it's best
you
to
can
download
download
the
it.
Yeah, you have to
application.
download it. It's really fun. There's like all sorts of games. Like,
So
like
you need to
every
download it on your laptop or your mobile device?
On your
laptop.
laptop. You can
Laptop,
on your
or
phone, but it's not as fun.
Yeah, the
okay,
phone
so
app
it
is
has
really
to be a
bad.
laptop.
Yeah, there's only one game that's fun on the phone. So
Okay. Then I can't use it on my work computer. I'll have to use my personal computer.
Are you actually getting it? We can play together.
I'll have a look at it.
Yeah.
Problem is I'm on
Yay.
my work computer right now, and we really can't install anything on our work computer. They blocked it.
Mm.
So even if it's educational program, we need the administration to actually push it down to us. So, but on my laptop, I'm not gonna have any problems with that. I assume because it's you're downloading an app, right? Is it compatible with Mac?
Yeah.
Yeah.
Yes. Oh, cool.
I can tell you all my favorite games.
Is that the only thing you've been doing?
No, I've been studying for the AP Chem exam too.
Oh, cool. Now, crying is the most important. It's the most common thing. Crying. Why? Because you're starting to. Some of you broke up with your boyfriends, or what?
That's not that. It's not
Not
that.
that.
Have one to begin with. So.
Yeah.
You're funny,
That's the
Dr. Rowan.
That's the only reason why I can think you can be crying.
What if I'm crying because I miss school?
Yeah, what if I
I
miss
miss
my
my
friends?
friends.
Ah, you're lying.
Stop playing Roblox.
Is Roblox so big?
Oh my goodness. Bad sleep schedule. Man, I can relate to that. You know what time I sleep?
What time?
What time?
5 a.m.
Okay, the earliest I've slept this past week is 2 in the morning. The
Oh.
earliest.
Dr. What were you staying up for?
Yeah.
I can't sleep.
Aww.
So TDUs, let's get back to school. Some are time consuming. A lot of work. Okay. Huh. I'm wondering though. See, just in case you don't know, from the side of teachers, we were actually asked to make sure that we stick to the time frame when it comes to classes, and these are just core classes of the schedule, and it should be limited to 30 minutes a week. Of course, it's different for AP courses because that's an exemption, especially if we're preparing you for the AP exams. Um, if is it because you are taking mostly AP classes, or is that also the case when it comes to assignments that are not AP?
Just my AP classes, honestly. I'm not gonna lie, I don't really try in any other classes.
Yeah, that's true.
Yeah.
So it's mostly it's time consuming and stressful because of the AP classes.
Yeah.
Yeah, but just the AP test too. Like
Yeah.
online work is just like it's mostly I feel like a lot of classes are just busy work.
Yeah. That's what I was thinking, because even the ones I assigned for my pre-AP, I feel like it's more like busy work for my level of students. But problem is, it has to be common for all the AP, for all the chemistry classes, regular and pre-AP. So I have to do it that way. And what I'm doing though is I'm actually doing some extension activities. And my concern right now, and in my road, I'm actually doing a road ahead session with my students this afternoon too in pre-AP. And the part of that agenda is actually getting them ready for AP chemistry next year. So we'll see how that goes. My biggest problem for my pre-AP, you know what? We skipped the whole topic of stoichiometry.
Oh.
Oh,
that's
how
not
is that gonna
good.
work?
I know, because that was the lesson for April.
Oh no.
For March, rather, when we come back, when we were supposed to come back for after spring break. That was the lesson. And that's the whole lesson they skipped. We went straight to nuclear chemistry and then gases. And nuclear chem is not even part of AP chemistry.
Yikes.
So that's my biggest concern right now. Any suggestions? I'm open to it.
Download Roblox.
No?
Okay.
Are you willing to coach my students next year?
I'm willing to.
Yes.
Sure.
Yes.
All of us can.
You're not gonna tell them that not to take AP chemistry, right?
I
Because
love
it's
AP
hard.
Chem.
Not.
Because it's so
We'll
hard.
see.
No, AP Chem is the best.
Who said that?
That makes me sad.
It was me. It was me.
We know.
Okay. So at least I have an idea where you stand at. What's a trigger fish?
Shrita, pull it out.
It's
I can show you a picture.
yeah, she'll show you a picture.
Uh-huh.
I want new friends.
Shrita, you get a better picture.
Get a better picture. What is this?
Get a better picture.
Fine.
And she has multiple pictures.
His name is Hubert.
What?
He has a name, right?
Mm-hmm.
Since when did he have a name?
He always has a
Thanks,
name.
Anne.
He never had a name.
I was never a fan of Doogie Fart.
He never had a name.
The press. Why?
The truth was spoken.
the AP test, I think. I think that's why.
Because we're stuck inside for like.
There you go, Dr. Moan. Look, that's a triggerfish.
Years.
Okay.
Do you have one, or is that a? Is that
It's a special one. He's the
freshwater
best
fish?
He's
It's just a
a very
random fish
special
that she's
fish.
obsessed with.
No, stop.
Yeah.
No, too far, Tonya.
Special.
That's her boyfriend.
He's a very special fish. I painted him on my jeans too. He's just that special.
His name is
Really?
Hubert. And he gives.
His name is not Hubert.
Why is it special?
Because you know what? I'll put the video as my background. Give me 1 second.
I think it looks like a Shrita, personally.
I think it acts like a Shrita.
So like she
Are you
has
calling her orange? That's racist.
Okay.
Hey,
I'm saying that is what I'm saying.
there's 12 participants. Where are the others? Are you lurkers?
they're lurkers, Dr. Moon. They're hiding.
Yeah, kick him out, kick him out, kick
I
him out.
know.
Turn on the
Grace was
camera
at the
right
grocery
now.
store, what you do?
The aggression.
Come out, wherever you are. I knew it. Coral just woke up.
You're really calling her out.
Let's see.
Isabella, you're the one out of quarantine. What are you doing in school?
You're right. You're right.
Go back home.
I
Right?
didn't think they'd catch me.
Okay, I don't know how to download YouTube videos, so I can't make it my background. This is really sad.
Yeah. Okay.
How are you, Daisy?
Oh my God, Daisy's here.
I'm good. In the kitchen.
Where are you headed, by the way? Have you
Oh,
committed
for college?
to? Huh?
For college?
Yeah?
Oh, I'm probably going to UNT.
Whoa, UNC.
No, I said UNT in Texas.
Oh, UNT. Is that North Texas?
Yeah,
In Denton.
yeah.
Ooh, cool. That's not far.
It's not.
That's like 4.5, 5 hours away, right?
Yeah.
Just north of Texas, of Dallas.
Mm-hmm.
Are you playing for varsity there or what?
I don't know yet. I haven't talked to the coach, but I plan to before
Mm,
I get on campus. So we'll see.
nice. Ooh, I love your idol, Isabella.
Yeah, he motivates me every day.
Sim jumped out. Oh my God.
Look, he's holding a
Looks
suicide.
looks like Brad Pitt. Ooh,
Suicide. Oh, look at the fish.
oh, cool.
Who gave Isabella internet access? I think that's the question here.
I hate it here.
Hate it here.
I love the video, Shrita.
Thanks.
Nice.
It's just the same.
Do you actually have a triggerfish to take care of? As a
Sure.
pet?
I wish I did though. This one in particular, my favorite triggerfish on earth.
Those are fresh water, right?
I have no idea.
Oh, you
James,
don't?
you don't love him.
Yeah, I don't-
Yeah, it's hard to say if it's a freshwater or a seawater, and because there's no perspective, I don't know how large that fish is.
Mm.
I think it's like this big.
About, yeah.
Why is that such a thick fish?
It's very long.
Big.
It's so thick, but it's just this flat.
It's like 11 inches.
I know.
Yeah,
It
that
really
research.
Big, but big.
Look at that was a good one. Oh, wait,
Where's
wait, wait.
Christina?
Wait,
I'm
wait,
gonna
he's
call out Christina, Success, and Marilyn.
Marilyn was on there she was on video call for like 2 seconds and then she
Oh.
Okay.
Wait, you heard my voice. I'm just not turning on the camera.
did. Why not?
Turn it
I don't
on.
feel like it.
Don't be shy.
I don't
Turn
feel
it
like
on.
Nah.
Turn it on.
Oh man, Christina is living a hermit's life now. In the, what's that? In the North Pole? Hey Marilyn, how are you? Why is your face like that?
Because I just woke up.
Looks like you woke up. You just woke up.
Mm-hmm.
I no one's gonna know.
Dr. Mon, I'm tired.
What?
It's 10 in the morning.
You should take time this weekend to relax.
Yeah.
And then do my diagnostic test.
Yes.
John, why is it so long? That's like a good.
It's like two separate, think about it in this way. It's like two separate free response tests this year. If you think about doing it one question at a time, the way I divided it, only one of those questions requires you, more or less the time limit is 25 minutes. The others are just 15 minutes each. And there's 7 questions.
Oh, okay.
So, and you have the whole weekend to work on it. That's why I placed it on a weekend. And it's a window so that you can afford not to do it separately. I do want to make you aware of the time so that you are able to, if you want to and you can afford it, you can do a simulation of the actual exams, because that's the best way to prepare for the exams. It's not only being able to get the answer to the question, but getting the answer to the question within the time limit, because it's a timed test, right? So the best way to prepare for the test is really exam situation. So if you can afford it, do that. And if you want to note which question is actually 25 minutes long, it's question number 4 out of 7. The other 6, they're 15 minutes each, the time limit. So if you want to time yourself per question, that's how you're supposed to do it. The one on Tuesday, Thursday, and Tuesday next week, those are more of, I want you to take that as exam type of questions, meaning when you take it in one sitting, time yourself so that you have an idea where you stand at. Okay? Because at those ones you use for testing yourself, that if you can get the answer, how much of a correct answer can you get within the time frame? Okay, so I hope that makes sense. Now, what are you showing us, Ashrita? That's the office, right?
Yeah, it's Michael Scott dancing.
Yeah. Ooh, yeah, that reminded me. I still need to see, Arna, dance. So,
Where is this coming from?
actually, that's the last thing on my agenda.
Okay, I don't know about that. I'm gonna have to head out.
Just in case you don't know, before you head out, see the last thing on my agenda, end of year celebration. I actually wanted to have a do this again about a month from now, which is next right around May 20-ish, after the exams is over. I wanted us to actually schedule a time to do this again, but the agenda is more of just end of year. Let's have a celebration and let's have some performances. Yes, Arna? Yes. Maybe some, if you're good at singing, sing for us. If you have a talent, show us your talent. And at the same time, I also I actually try to do this every year, except last year I wasn't able to do it. I mean, some of you might have heard it and you were anticipating it highly last year, probably, but I never got to do it. I didn't have time because I was out for 1 week for international fair. But I actually always end the year with a celebration, and I actually give you an idea of how I'm gonna remember you. In terms of, I also give you a certificate of, and I do that in the form of a certificate. You might have heard that from my previous classes. Last year was the very first time I wasn't able to do it. And I'm sure, I surely do not want to miss it the second year in a row. So I'm thinking of doing that again this year, even virtually. So just look out for that. I'll think about the details of that some more. But one thing I wanted to do is, because we're doing it online now and it's both classes, we'll have more time to, I would say more time to actually do presentations. So before I tell you how I'm going to remember you, I need you to show off your talent. So Ashrita can probably show off how good he is at playing games. But Arna,
Yes.
you're going to dance.
No. I'll join Ashrita. Me and Ashrita are a team on Roblox.
Whoa, hold on. I think I'm
No.
the best.
No.
You can record yourself, or
Yeah,
you can,
Angela, speak
you
up.
can do it live.
Live stream it.
I can share my screen and
Can
share
we
Roblox.
screen share?
That'd be
I
so
can do it right now.
I might join my Twitch.
Can I join them?
Wait, can I join? I'm not that good, but like I
That can be my talent.
Let's
I'll
ask for
join them also and
something.
play.
Me and Izzy can be the joiners. That's
I
how
watched 7 times.
I'll play Minecraft.
I can't play Minecraft though.
You don't have my
I'm not really doing much.
I can play Minecraft.
So if you want to do it in terms of video of your talent, send me a snippet.
I don't have any.
I don't have a talent, doctor.
Oh, yeah,
When I
right.
wanted this game.
Okay.
Yeah, but that's what I was planning on doing. So think about that. It's about a month from now or so. It's definitely after the 20th of May. We'll just do that, and it might be a good way to wrap up the school year. Okay. What the heck is this? Anyone who would like, I don't know what language is this. Is this a, this is an alien language. What does this mean? Yeah, we don't even know if we can go back to our to campus and fix up our stuff. I definitely have a lot of materials that are laying around and lots of chemicals laying around because I didn't have time to put them up. I don't know how that's gonna work.
What?
Experiments over Zoom.
Huh?
You should do experiments over Zoom.
Yeah, that's a different thing.
Yeah, let me
I
go
can,
get my lab equipment. I'll be right back.
my concern is that physically my room is a mess. And so I just need one day to fix up everything, pack everything, and be done with it. But anyway, it's actually nice to see everyone's faces. Now I can always review the video if I want to recall. Who is this student again? How does she look like? Because I haven't seen everyone in a long time. So I hope we can do this again one time. So next week, I'll let you know through Remind when I've done I've checked everything. But if you haven't finished any of the assignments, go ahead and start working on those as well. Don't stress yourself out too much on those assignments. All I need to see really is that you worked on them, and I'll give you some feedback, of course, on those assignments. But for grading purposes, don't stress yourself too much on it. Just give it your honest effort and be done with that. At this time, if you were to focus on assignments, it would be the ones that would help you for the AP exams. All right. And if you need anything, I'm just a remind away. And for some of you, you even have my phone. You can text me and you can call me. I can definitely, because I'm by myself anyway. Not like I have much to
Dr. Ron, you
do.
can play Roblox with us.
Yeah, can we play Roblox together later?
I will
Whenever
definitely
you're free.
download that in my other laptop.
Okay.
Roblox, right?
Yeah, when do you want to play?
Dr. Mon, for the assignments, do you mean like the free response questions or like the lessons on Schoology or like the OWL or just like
Well,
all the slides?
If you refer to this slide, pretty much everything. Oh, is this though? Oh, this is pre-AP. Oops. I was saying, that doesn't look right. This one is what you want to refer to.
Okay, so as long as like we try all those lessons, it doesn't like matter. Is that what you're saying?
Yeah, this is for T4 rating, right?
Okay.
So for T4 rating, really these lessons here, the ones on top, that's for the progress report. These are the lessons on thermochem. Okay. Now the progress checks in AP classroom, that's not gonna be until that's part of the diagnostic review. Okay. But what I was saying is this: don't worry about these assignments over here on top. Just attempt them, give it your honest effort, and just be done with it. I just need to see that you attempted it for this portion. Okay? Because you can always go back to it to review thermochemistry stuff. My concern now is you focus on this at the bottom, starting from today's assignment, which is a diagnostic test, and everything that I've assigned you in AP Classroom, we're going to be focused heavily on AP Classroom. Most of the assignments, I'm going to draw from that's going to go in your T4 rating are based on the AP Classroom stuff. See, all of these are AP Classroom. Even the optional student practice, that's AP Classroom. Okay, I'm not sure if I still have it pulled up. If I can pull it up, I will. Let me see. Oops, wrong button. There you go. See, the diagnostic tests are assignments I've assigned you. These ones. Okay? And they're already all programmed there. It's going to open up in the correct date. But beside that, there are actually optional student practice. And these are actually all available for you now. There's a tab there for optional practice. And based on the results of your diagnostic, so supposing that it shows that you're weak on Unit 3, for example, then you look for Unit 3 assignments here and then attempt those. If you're weak on Unit 5, you attempt this. So that's what you're going to be doing in your individual practice. In addition to the paper-based reviewer that you have with you. And there's a lot of this. I'm sure there's going to be a lot of this that you can use. And what they did here is they actually filtered it out so that it's actually every single question here are part of the coverage for the exams. You will not see here any Unit 8 and 9. See? Okay, so that's what I mean by this optional student practice. This I assign to you. This is not assigned to you. Okay? So just before we, as much as I wanted to be here the whole day, we need to cut it off somehow because there's still some things what we need to do. Before I end, any concerns or last minute chats? Yeah, Ashrita?
We're actually playing Roblox, right?
Yes, we are.
Okay, wait, what time? What time?
Once I download it.
You should download Discord too, so we can talk over.
Huh?
We can all start a Zoom meeting and we can play Roblox at the same time.
I'll let you know once I've set it up, and I'll send you a message in remind.
Okay, I'll send you my username so you can friend me.
Okay. Cool.
Can you send all of our usernames?
Nice. I'll tell you my favorite games. I'll give you a whole tour.
Judy, you have 2 games you play.
No, actually, I've played lots of games in Roblox. I'm a Roblox veteran.
Oh man, so you're gonna be our resident.
Robloxian.
I think we should start easy with Dr. I think we should start with
Dr. One, you're gonna be the newest Robloxian.
Yeah.
Is that skill-based or is that an intellectual game or?
I mean, it's like anything you want because it's like a platform, but then there's like thousands of games on it.
It's kind of like are they more arcade type of games or word games?
No, there's a bunch of there's different ones. Like there's a shooter game I play.
Collection of different games.
It's a bunch of first-person games.
Yeah.
First person. Okay.
Yeah, they're pretty fun. There's like anything you want.
So kind of like role playing.
Yeah, basically.
Kinda, yeah. There's games about fashion. There's games about robbing.
Yeah, there's like rip-off like of actual games.
I actually haven't played
Call of Duty rip-offs
an RPG game in a while, because I play more strategic simulation games.
Dr. Moon, do you play League of Legends?
Nope. I'm a Star Wars fan, so I play. Yeah, I play Star Wars Galaxy of Heroes
Oh.
because it's Star Wars.
There's Star Wars games in Roblox.
Are they really?
Yeah, there are. Remember you played one? Oh, never mind. I think I played it with Angela.
Interesting. Okay.
Yeah.
I'll check it.
Just shoot me a remind and I'll be there.
Okay, cool.
It's exciting.
It might be a bad influence for me, Ashrita.
100%, yes, she is.
Oh, like you said, it's a stress reliever.
No, but all the games are made by
Why is your dog talking?
There's somebody in the front yard and he keeps on barking, so my mom said to bring it in my room, and I just don't know how that's gonna help. So yeah, there you go.
What's his name?
His name is Ace. She won't answer, but
it's Ace.
Ace Abraham.
Ace Abraham. Okay, cool.
Ace helped pick the name out.
that's a lot.
It was actually my suggestion.
Oh, was it? Okay.
I remember that
You
day.
sent like 90 names.
No,
She's
wait,
gonna pick
Ashita,
one.
I thought you suggested Oreo.
No, I suggested Ace too. It was actually one of the first names I suggested, but then Isabella didn't like it. But then later she picked it, so I was like,
remember I second Ace. I said that's a good name. That's all I
How
remember.
long has have they had him?
2 years.
2 years?
Yeah.
Oh, okay.
Bring him back.
Long already.
I don't want to see you.
yeah, we want the dog back.
Okay. No, he's gone. He's still barking.
Dang, should I bring my bunnies in?
At this point.
Yeah, bring your bunny.
Can he do tricks?
Yeah, he can shake, fist bump, sit, high five.
Oh, cool.
Wait, can he
That's
go
it.
like this?
Can you go like that?
No, wait, did you teach him the sup thing, Isabella?
No, I tried to. He would just sit there and be like, yeah.
Aww. Can we all
You should
bring
video yourself with your dog playing tricks.
Naisha,
Can
go
that
bring
be
your
my
baby.
talent?
Yeah.
Sure.
The
Yeah,
dog
get-
trainer.
Do a video and then, or actually you can do it live. You want to.
Angela,
Yeah.
bring Charlie.
Yeah, bring Charlie. Do it.
I love
Charlie.
Charlie's your
Who
golden
is
retriever.
Charlie and Turtle.
Charlie's her
intrigued.
golden retriever.
This is my pet. His name's Hubert.
He doesn't want to come. Come here. Well,
I don't even know what type of fish he is.
He's a trigger fish.
Aw.
Hi, Charlie.
It's
Charlie.
no way. Come here.
How old is he?
He's 3 years old.
Charlie.
Wow.
It's a bunny.
Bunny. Yeah. Oh, wait, I want to see the bunny.
This is my Charlie.
Oh,
And who is that, Naisha?
that's Charlie too. Oh my god.
Charlie too.
Charlie's a popular name.
That a
It's so cute.
that's a hair.
Yeah, it's a bunny. It's a bunny.
Initially, I thought it's a cat, but it doesn't look like a cat.
Very small cat.
That's a decent size if it's a cat.
It's so small.
It's not, right?
Not cat.
Wow.
Oh.
Everyone, bring your pets.
Huh?
It's pet day.
My pet?
Bring your pet to school day.
Yeah, bring your pet.
Wait. I'm not in school, so I have like 140 of them.
Oh, it's a kitty.
Yeah,
What's the name?
but
What's the cat's name?
Yeah.
His name's Cairo.
Oh,
So cute.
Very cute.
How do I oh, because I'm doing a I'm sharing my, there you go. Now I can see everyone.
Come here.
But if I share my screen, I'm just playing around right now, okay? Then it's only the six at a time, huh?
There's a way to do grid view and then you just pull at the edge where there's little lines.
Huh?
There should be a place where you can click grid.
Here?
It has it like in a line, right? Yeah.
Yeah, I don't see it. For full screen video clip. No, but that's optimizing it. Video setting.
I have to go. Bye.
Yeah. All right.
I'll see you
We
when we
need
build
to
Roblox.
end at this point because I do have things to do. I'm gonna be on another meeting. But it actually was great to catch up with everyone. Again, we'll do this again later on after the exam. All right. Bye, everyone.
Bye,
Dr. Moon.
Bye.
Have a day.
Bye-bye.
Have a good weekend.
Yeah. Bye. Thank you.
Bye.